Hello fellow math enthusiasts and learners of mathematics. In this video, language meets math and have an epic duel. Maybe not. But in this video, I'm going to highlight how language and math interact with each other and hopefully take some of the confusion out of integer addition and subtraction issues. I'm going to start with focusing on some of the language that's represented by the cross and the dash symbols, and then we'll walk you through two examples, one integer addition and one subtraction example, to show you how the language and math interact and hopefully again take out some of the confusion from integer operations. The prompt came from an idea in class from a textbook. Many of the textbooks involve some of the concept here, or include some of the concept here, how the notation, or the mathematical notation, is different from what people say. Okay, I can't really highlight it, but this column here, and or this one, as well as this could be also spoken. So how spoken language is different from written language, but there are some integer operations where that's just not enough information to get the job done. So let's get going with synonyms underneath this white space there. These are synonyms, meaning this multiple words having by and large the same meaning. What I mean by that is when in math the cross symbol is used, people in English typically say and or add or plus or positive, but there are other forms of or figures of speech such as more than, increased by. Same works with the dash symbol. Some people, most of the time people say take away, but subtract is also good. Minus and negative are also synonyms, as well as lessened by or decreased by or less than. So there are other figures of speech in use as well. So when it comes to doing math, I'm going to show you in this example how some of this language works out and how the BADMAS rules will take out all the guesswork from the confusing synonyms. BADMAS is brackets, it's an acronym, brackets or parentheses, exponents, division and multiplication, and lastly addition and subtraction are done from left to right or in this priority. So brackets or parentheses depending on what language area you're from. The following example here is from a math book evaluating an expression. The expression is n plus 2, and evaluate means to come up with a value that replaces this whole expression. So in this case, learners would be required to take this -6 and replace n with that -6 so that it initially reads like this, and then reduce it or solve it to have only one value on the page instead of two values or two numbers. The answer is -4, but how this is read out loud is what can be confusing sometimes. So out of these four synonyms here, especially the first three have an additive sense to them, meaning addition. So -6 and 2, or -6 plus 2, or -6 and 2 added to it. These words here, these synonyms, have a sense of integer, because this too can be thought of as positive 2, not just a number, not just a quantity, but a quantity with the sign in front of it, the sign and the number thought of as being one unit. Its adjective is the sign and the quantity is here, so it's a 2. What kind of 2? Oh, it's a positive 2. Okay. When I was a kid, this is how I thought of numbers, always having a sign or an adjective or a magnitude to them, and math could be printed. This is implied. This sense is always implied to positive numbers, so the same expression can be printed this way, but by math convention this is what's typically printed. And if I can put that plus back here, a -6 and a +2. So this is how it read to me, and this is where BADMAS rules are really important. The -6 and the +2 need to be combined without any disregard to the language that might be causing this confusion, that the additive sense is not the same as the integer sense of this cross sign. So this one equals -4. It doesn't matter how it's printed. The following example is going to be with subtraction. It's going to be a little more confusing because there are two subtractions in it, and these two subtractions or two dashes can end up side by side depending on how it's being solved. So I want to do the same thing and overlay some of the language here. This can mean the dashes can mean can have a subtractive sense, as in take away or minusing, or they also have an integer sense there, an integer sense meaning a negative number. So this could read 17 take away 4 or 17 decreased by 4, but this decreased by is the same as -4. Having the thought of this 4 as a -4 again in one inseparable unit, and in this case the 17 gets increased by a -4. Just ignore the rest of it, okay, for now. So this is also a valid way of printing integer subtraction, but usually by math, by convention, the positive sign is usually omitted. So with this pointed out, I want to solve it step by step very quickly. Brackets first, according to these rules. So brackets first, there are no exponents, so let's deal with the bracket or parentheses. 8 minus 11, 8 take away 11, 8 lessened by, it could be 8 take away 11, or 8 combined, a positive 8 combined with the positive 8, as in one unit, combined with, and this is the additive sense, and this is the integer sense again, combined with a -11. So when you're done with the combination, the result of this operation is -3. Now for the next step, and I forgot to point out, but that's what my notes are for, there is an invisible multiplication here in this space between the subtraction in the bracket and everything else outside the bracket here, just between the 4 and the open bracket. So next thing is this multiplication that needs to get done, and 4 times 3 is 12, but purposefully I'm thinking of this 4 as a +4 in and of itself, +4, and this dash as a subtractive dash. I could be thinking of it as an addition of a -4, which mathematically is exactly the same when it comes to the final answer. So I'm going to solve it both ways, you'll see. So in this case, what's highlighted, +4 multiplied by -3, and the bracket has been dissolved or resolved. The bracket is in place here just to indicate this that there's a multiplication here to be done. So 4 times 3 is 12, and it's a +4 times a negative number, so that's -12. And this subtraction dash just got copied down from the line above, and the 17 gets copied down from the line above, and are unresolved just yet. We haven't dealt with it yet. So right now this can be read as 17 minus 12. With the two minus words having two different meanings. The first one having a sense of subtraction, the second one having a sense of integer, this being a negative 12 or minus 12, or the opposite of 12. Now this 4 can be thought of, like I said, as a negative 4. I'm going to solve it here in this space roughly to equal 29, either which way we look at it, because negative and negative, meaning it's a double negative. There are no double negatives in English, but it's an opposite of an opposite. So we have positive 12, the opposite of positive 12, and then we don't have the opposite of positive 12. When we don't have a negative thing, say a broken leg, when we don't have a broken leg, that's a good thing, that's a positive thing, so that becomes a positive, and it's 29. Now when this minus 4, this 4 is thought of as negative 4 in one unit, then negative 4 times negative 3 becomes, I'm just gonna copy this one over here, then it becomes 17 plus 12, where negative times negative is positive, and 4 times 3 is 12, and this 3 is a negative 3 in this sense as well. So either which way, we end up with positive 29 as a final answer. Probably one other way, one clean way of thinking about this whole expression is 17 take away 4 times the difference of 8 and 11. And of course, in real speech, in real life, nobody speaks parentheses or brackets into a sentence, so this is implied here. So regardless how the integers are thought of, whether as subtraction, or this is an integer, or this is an integer and that's a subtraction, and whether there is a plus sign here or not, likewise, whether there is a plus sign here and here or not, using the BADBAS rules, the same number, 29, can be calculated. And admittedly, so language is confusing the math operations, but these BADBAS rules, the order of operation rules, are pretty clear, and I find it really useful to follow those steps, keeping in mind that sometimes these signs have these double meanings, and regardless of the meaning, the correct number you can still arrive to if you keep in mind the two distinct senses of the signage and follow the order of operations.